Welcome to this explainer. Listen, I'm really glad you're here. If you've been tasked with building integrations for Business Central, well, you're about to learn a pretty hard truth. What works perfectly in a nice, safe, quiet sandbox will often get absolutely crushed in the chaotic real world of production. But hey, don't worry about it. Consider me your senior mentor today. We're going to transform those fragile web service calls into a completely unbreakable enterprise-grade architecture. Let's really look closely at Microsoft's actual survival guidelines for troubleshooting and performance so you can build integrations that actually, survive.
Okay, let's just quickly breeze through our syllabus for today. We're going to start with the rookie anti-patterns you need to drop right now. Then we'll move into optimizing for pure speed, handle massive data throughput without crashing the whole system, and finally, look at how to debug production environments like a seasoned pro.
All right, Section 1, ditching the rookie mistakes. We've all been there when we first start out, but we really need to stop treating web service endpoints like user interface screens.
Look, the absolute most fundamental architectural flaw I see all the time is exposing standard user interface pages as endpoints. Standard UI pages are just incredibly heavy. They actually force the server to load visual elements like fact boxes and calculate SIFT fields, which, if you don't know, are those complex background data summaries used for reporting. An integration backend literally doesn't need any of those visuals. Every trigger has to run for every single record, and you're just wasting massive amounts of compute power preparing elements that aren't even returned in your payload. Instead, you've got to rely entirely on API pages. API pages strip out all that UI overhead, completely bypassing visual calculations. The result? They can be up to 10 times faster. That's the baseline standard you need to be aiming for.
Now, let's talk about 3 specific anti-patterns you absolutely must abandon. First up, calculated fields and complex object types. When you query a calculated field, you force the server to execute logic on the fly for every single row. It is incredibly expensive. Just move that logic to a separate batch process or store the physical value right on the table. Second, temporary tables. If you're processing more than 100 records, temp tables are a total disaster. Why? Because they have absolutely no caching. The server has to fetch and insert every single record from scratch, which just destroys your paging performance. And finally, never ever insert child records of the same parent in parallel. If you've got 5 parallel threads trying to update lines on the exact same sales order, they're going to collide, and that causes severe database locks on both the parent and the integration record tables.
So how do we fix those parallel locking errors? The solution is sequencing. You simply must ensure your calls execute one after another. And the modern, elegant way to handle this is by using the OData batch transaction. Instead of firing off 10 separate requests that fight for database resources and just lock each other out, a batch operation bundles them all into a single payload. Business Central processes them sequentially under one umbrella, which keeps your database lock squeaky clean and prevents those collisions entirely.
Let's move right along to Section 2, optimizing for pure performance. We're going to see how to build a foundation that simply won't crack under pressure, and that means we need to talk about protocols and payloads. To truly architect for speed, you have to look closely at your protocols. The veteran move here? Completely abandon SOAP. SOAP is a deprecated protocol that relies on this bulky, heavy XML payload structure. It's just a huge drag on your network throughput. You need to migrate over to OData version 4 or API pages, which use lightweight JSON payloads. That alone multiplies your speed up to 10 times over. Now I know what you're thinking. What if you're stuck with legacy AL code units that seemingly require SOAP? Well, the modern workaround is to use OData Unbound Actions. Those let you trigger AL code directly via modern REST APIs, completely leaving that old XML baggage behind.
Okay, here is a senior-level secret weapon I'm going to hand down to you. Often you're building OData endpoints purely to read data, like, say, feeding a Power BI dashboard or some external reporting tool. For these specific scenarios, use API queries and set the data access intent property to read only. Behind the scenes, Business Central actually maintains a fully synchronized copy of your database. Setting this property routes your heavy reporting queries directly to that secondary read-only replica. It completely bypasses your main production database. That means your actual users, the ones entering daily transactions, won't feel a single stutter in performance while those massive reports generate in the background. It's a real game changer.
Now, a golden rule of integrations: never, and I mean literally never, pull the whole database. You've got to aggressively limit your data queries. Shrink your payload size immediately by utilizing the OData filter and top parameters. The filter parameter ensures the SQL Server only returns exactly what you need, cutting down processing time. And the top parameter forces pagination, so you're returning manageable chunks of data.
Listen, if your query includes an expensive expand statement to fetch related tables, limiting that result set is absolutely non-negotiable. If you don't restrict it, you're looking at massive memory spikes, long network transit times, and inevitably, complete client-side crashes.
All right, section 3. Imagine this. Your code works perfectly in the sandbox. You deploy it, and the very next day the client calls panicking because production is totally down. Why? Because you didn't plan for massive throughput. Let's talk about what happens when the system actually fights back.
When you move from a sandbox to Business Central Online, you are entering a multi-tenant cloud environment. You're sharing resources, right? So if your integration hits the API too aggressively, you risk slowing down the system for everyone else. To protect system stability, Business Central will proactively throttle you, rejecting your calls with an HTTP 429 status code. Too many requests. Now, it's important to understand this is not a crash. It's a deliberate defense mechanism. It's simply the server telling your app, hey, you're moving way too fast and you need to back off.
But if you just ignore that 429 warning and keep hammering the endpoint, the situation escalates fast. The server will throw a 503, service temporarily unavailable. Unlike a 429, which just means you are being too fast, a 503 means the server itself is now overloaded, heavily stressed, or maybe even down for emergency maintenance. Your external application absolutely must be defensively designed to catch both of these codes without crashing or just losing data in the ether.
So handling these throttling codes gracefully requires a very specific step-by-step strategy. First, when your request hits a 429 or a 503, do not drop the payload. Catch that failed request and push it into a local queue. Next, inspect the response. The Business Central service actually provides a specific retry after HTTP header. It literally tells you exactly how many seconds to wait. Read it and respect that cool-off period. Finally, implement an exponential back-off strategy for your retries. This means if the call fails again, you wait 2 seconds. If it fails a third time, you wait 4 seconds, then 8, then 16. This gradual decrease in pressure gives the server the breathing room it desperately needs to recover.
So to quickly recap, implement a queuing system to flatten out your traffic spikes, and always respect the retry after header provided by the server. But there is one specific status code you absolutely cannot retry your way out of, the HTTP 504 Gateway Timeout. A 504 means your single query took so long to process that the server simply hit its threshold, threw its hands up, and severed the connection. If you hit a 504, retrying is just going to cause another timeout. You've got to go back to the drawing board, refactor your code, and split that massive long-running request into smaller, leaner, and faster chunks.
Finally, Section 4. Let's talk about what happens when things inevitably break. How do you actually find the root cause and debug production environments like a veteran developer?
First off, we completely banish the phrase, "it works in my sandbox," forever. Seriously, if it works there but fails in production, the environment variables changed. Always verify the API user exists, is active, and has identical entitlements and permissions. When that fails, you turn to partner telemetry in Azure Application Insights. This is literally your X-ray vision into the server. You're going to want to query 2 specific custom dimensions, HTTP status code and failure reason. These dimensions bypass all those generic front-end error messages and expose the exact line of code or data conflict that's causing your REST call to fail.
This matrix right here is pure gold. Translating generic OData error codes into their underlying AL runtime exceptions is exactly how you debug efficiently. Let's decode them. If telemetry shows a bad request, you're almost certainly looking at an OData argument exception, meaning your JSON syntax is malformed or maybe you passed an incompatible property. If you see an internal error, the backend threw a nav side exception. That generally means the server lost communication with the SQL server or hit a deep data integrity wall. But if you see an application error, which leads to a nav test field exception, well, that's pure business logic. It means your data violated a Business Central validation rule, like, trying to post an invoice without a valid customer number. Knowing this translation is going to save you days of blind troubleshooting.
Okay, before we wrap, here is a massive gotcha for outgoing external calls. If you're using the AL HTTP client module to push data out of Business Central, the runtime actually blocks it by default for security reasons. You have to navigate to the extension management page in Business Central, locate your specific extension, and manually toggle Allow HTTP client requests to True. And the real catch? Whenever a production environment is copied to a sandbox or vice versa, this setting quietly resets itself to false. Forget this, and your outbound integrations will just instantly fail on launch day.
So, we've covered the dangerous anti-patterns you need to drop, the architecture required for pure speed, the absolute necessity of exponential backoff, and how to read telemetry like a real veteran. I want you to take these lessons back to your desk, refactor those heavy UI pages into sleek APIs, and lock down your retry logic. Because here is the final question you really need to ask yourself. Are you just building integrations that work when everything goes right, or are you building an architecture that survives when everything goes completely wrong?